Hello, everyone. I'm Alexander Ryzhkov, the head of AutoML Group, Machine Learning and AI, Sberbank, and we'll be speaking about LightAutoML, or Llama, as we call it. In the beginning, I would like to speak about AutoML. It's a tool which somehow helps us prepare this model with the data sets. We would like to work with raw data, so we need to have this AutoML as a technology which helps us automate this entire modeling and simulation process, like feature engineering, selection of the criteria, the optimization of the model, and creating of the model, validation, reporting, etc. There are basically plenty of AutoML solutions, as you can see on the slide. We have open source solutions, and we have AutoML from H2O, Amazon, TPOT, Autoscaler, and some other ones, proprietary solutions, Google Cloud AutoML, and others, as you can read on the slide. We have plenty of solutions available, so why did we decide to come up with our own? Well, we work in a financial institution, and we have quite a lot of models, like, for example, various types of data in the data set, numbers, unstructured text, categories, dates. So we have to very advancedly prepare them to get necessary features attached to them. The variety of different ML pipelines is crucial here. Each particular user would like to have their own model, so this solution should be customizable. Very often we'd see big data volumes, and the existing open source solutions, due to their brute force specifics, may work quite slowly. Yet another important parameter here would be us very quickly coming up with typical models. When with just one data set, we have lots and lots of target models for various segments, and we would like to reuse our knowledge about which model works fine on one target and use them at other models. Very often we see the tasks with the requirements from the regulator about making our model interpretable, so we have to take them into account while creating ML solutions. Those were 5 specific requirements. How did we resolve those? We come up with the cross-platform modular framework, which has an advanced set of presets and pipelines from the end-to-end solutions, and we of course need to speak about customization, so we just need to customize these presets at different abstraction layers, starting from feature engineering and ending with the additional blocks. The target audience for us are developers and DS, but this is AutoML. Therefore, the developers, those who have expertise in ML, they can tackle their tasks with our assistance as well. If we delve into this black box preset, I would like to show you an example of how it works on the slides. On the left, we have the data pre-processing, where we have automatic data cleanup, where we come up with a specified AutoML data set, with the categories, with the data, with the numbers, dates, numeric features, texts, etc. On the right-hand side, more to the right, so we have this model training block where we will just eliminate these garbage features. Those garbage features just make this model more complex but do not improve its efficiency. After this cleanup, we come up to the final model. And the models are learning not in the whole data set, but they are learning through the validation, so that we avoid, so that we would have the composition out of the predictions generated by these models. We do that. And since the predictions have not been relearned, the ultimate model generated is coming out pretty good in quality. And by the use of that hyperlink, you can drill down and use our tool for more detail. From the left to the right, we can see the entire process when we have these ML representation and description. We can integrate with different data sources. We can extract different types of attributes out of them, have the validation scheme, come up with different algorithms, make reports, and on later stages, we just switch to applying this model in the business and have the model inference in the prepared inference environment. However, there are plenty of AutoMLs in existence. Seems like that we need to compare them all and choose the best one. ICML 2019 had a workshop which explained this OpenML benchmark, which was pretty straightforward, and the authors came up with approximately 35 data sets from the OpenML website with the binaries and multi-class ones. Each data set required a 10-fold cross-validation. To build the model, the limitation was a 9-fold one, and it was limited by 1 hour and 8 cores of the CPU. To really understand how to benchmark these AutoML solutions, we use 3 benchmarks, 3 methods. First of all, it wins by task metric count. So the first bar stands for small binary data sets, the second bar for medium ones, and the last bar for multi-class data sets, where the landscape was different from less than 1,000 objects to dozens and dozens of thousands. The first line reports the number of wins, task metric count. The second line, it's the average position on the leaderboard, mean leaderboard position between AutoMLs for each task, and the lower one is the mean normalized solution score for each task. We are talking about quality here. Therefore, for binary classification, ROC-AUC was required, and for multi-class classification, log-loss was required. This benchmark is quite open. Down there, I would like to show you a link. By drilling down that link, you can find out how we've been launching these solutions, which have already become available. This particular slide is showing official results provided by the organizers. It's important to note that these bar charts show that for small data sets, which were no more than 10,000 lines, all of the AutoMLs were quite comparable, because the brute force nature of all of the AutoMLs really allow us to apply them to such data sets. But if we take a look at the average data sets and multi-class data sets, brute force is not much of a help here. Therefore, the LightAutoML wins and demonstrates far better results than its competitors. I was talking about a very important interpretation of the models that need to be created. Thus, we suggest that we use a specific preset here, which is capable of making an interpreted model as the classic scoring card model, with minimal possible decrease of quality comparing to black box AutoML. Right now, on the left-hand side of this slide, we can see a scorecard. With its use, we can very quickly identify the value for the points, and based upon these scores or points, we rank the customers. On the upper right-hand side, you can see the split of this our variable and NXT source 1 into the bins, where we have this voya change transfer, which is used in financial organizations, and it shows the mean average from the win and different between this and the mean average and the current selection, and thus we can use it for interpretation of the model. Down there we can see some bars in the bar chart showing the coefficients for the logistics regression model. The logistic regression model is used in this preset. There should be negative ones to make sure that we have a normal monotone dependency. This is not just a solution. This solution is very actively used in the bank. And the next speaker, Nikita Varganov, is going to tackle this solution, which has been implemented into their system, which they have been using constantly on a regular basis. I would also like to provide you with a link to the repository where you can drill down and make your own estimates on whether it would be suitable for your situation. Right now we are moving to the advantages of Llama. First of all, up to 10 times faster, significant time to market reduction, up to 70%. How can we integrate Llama with inference? I'm showing here the Llama with Sbercloud. On the left-hand side, you can see a user with the use of the LightAutoML. They're creating a serving script-based model, training model, which is moving to the cluster inference cluster, and then with the use of the automated assistance, it withstands all of the queries because it can be automatically scaled up or down depending on the number of queries. Follow that link for more information. The actual Llama usage is the way for transferring state-of-the-art solutions to industrial developers and DS. It has lots and lots of customization capabilities, and if there is a new solution coming up, you can quickly add it to our framework, and the DSs will be using this for their work. With the use of the AutoML and Llama, LightAutoML, we can increase the quality of the implemented models. LightAutoML works on top 10% human data scientist level, much better. And here we can see on the left-hand side, we can see some story about this Google article. Google competition, AutoML benchmark AutoML versus DS. Only top specialists can beat the machine model quality. People, of course, can win and beat the machine, but only if they are really top specialists, and if these top specialists have sufficient amount of time to beat the machine. On the right-hand side, we have this AutoML versus average DS in Sberbank. Right here we can see it's our hackathon which we had in Sberbank. AutoML is 90% above data scientists, and top 10% of data scientists are different from AutoML results. So speaking about yet another competition, we've been involved with this megaphone accelerator competition, which was following the Data Fest 2020, which was a disbalanced multi-class classification. There were 3 classes, and other classes were a multitude. The time to create solution was 11 days, and the participants count was 97. And it took us 1.5 hours to come up with a solution which took the 12th position with 26 places on the charts altogether, which comes up as a more reliable and stable compared to data scientists involved. With the use of the AutoML, we can tackle lots and lots of models which do not stand alone as profitable ones. A quick example: with the use of our solution, we came up with 55 models, and it took us just 1 weekend with a mid-range server. This particular chart is showing you a real advantage of the benchmark model and the AutoML-based models. Seems like that in most of the cases, these baseline models do not grow much, and sometimes you can see that they end up negatively. But with the whole effect combined, we can see that this financial effect is comparable with the business-critical bank task resolution. So we've been able to come up with lots and lots of models in a very short space of time. And manually, people would not have even tackled them, and there would have been no way of tackling them manually anyway. With the LightAutoML usage, we can do lots and lots of approach in determination of whether this new data source is good enough, sufficient for this new task, or alternatively will be just deteriorating our time to market model, and it will not be adding any profit to us whatsoever. And we can validate these models based upon the results, the AutoML results, because yes, again, we would like to understand what's best to send to production, whether it's a human-made model sent to the production, or alternatively an AutoML-generated model, which was generated automatically. And last but not the least is the handicap removal, so to speak. There is no way or no point for us to make these models forever, for many years to come. Right here on this slide, on the left-hand side of its slide, you can see that 2017 and 2018 were used as a train, and one statistical model was applied over February, March, April, etc. But since it's AutoML, we can gradually expand this training data set, and we will be saturating it with new data, thus removing the handicap taken into account new dependencies, which may be very important for this test selection. And down here on the slide, on the right-hand side and left-hand side, we do this comparison of this static model and dynamic model with this 1 month overdue. There could be this approach with one sliding window by adding months in the end and throwing away the months in the beginning, or alternatively expanding the data set and covering more and more data together. But both the ways are quite ahead of the static model anyway, and they can be generating far more profit for a bank or any other company that utilizes this model. LightAutoML is an open source framework for developers, data scientists, data analysts. You can follow the link on the screen. You can drill it down and take this tool and apply it to your tasks. With the use of this tool, we can come up with typical ML models in a very short space of time by using a simple laptop, well, with a better than average DS quality. This model, of course, does not generate any funds for us before the complete implementation, before it actually starts being used for the business. So you can alternatively come up with a Sberbank cloud-based solution to put it into production. Thus, I would like to end this presentation. Thank you very much for joining me here. And once again, I would like to show my credentials, my contacts on this next page, and I'd be happy to take your questions, if any. Thank you very much, Alexander. It's very nice that you have decided to open source this library. I think all of the viewers will be able to give it a try. Yes, we'll be delighted to. We are quite open for any feedback, because this is a real open source solution, and the whole community can quite conveniently and calmly tune it up and brush it up for their needs, because this is a solution with customization attributes.